Welcome today to our work with word problems. Now, word problems are something that typically are quite a bit dreaded in math, but there are a couple things that you can do to make word problems easier. Now, we're going to be looking at today our specific word problems. We're going to be looking at linear word problems. So that means that we're going to be doing stuff where there are no powers. And we're also going to be looking at word problems that are comparisons. We are really trying to set up two situations that are equal to each other. And this is just kind of like to dip our toe into the water when it comes to setting up word problems. And as we do this, I'm going to start by having you guys look at two possibilities for numbers. Now, in linear equations, there are a few possibilities as to what sort of numbers it will give you. And for the first few, I'm going to have you just look for slopes, also known as rates, and to just look for constants. And the way that you can tell these two numbers apart is in an algebra problem, a rate is going to look like something like 3x, where you have the coefficient being the rate and x being the variable or the number of times it is done. And a constant is just going to be that single number like 16 or -2. Now, in a word problem, these look very different. And when we're talking about these, you can usually tell something is a slope because it will be added or subtracted repeatedly. So I'm going to, like add 3 every day or something like that. So it's happening over and over and over again. And so you know to drop that x after the 3. Constants, on the other hand, will be added or subtracted just once. And it's usually considered our starting point. So it's an amount that you pay like right at the beginning or a height that you start at. Those will be just added once or subtracted once. So that would be a constant. So let's try these out. And we're actually going to do this with what I do, and that's generally for budgeting. So let's look at rock climbing. At my rock climbing gym, a student can use this gym, which looks like this. It's very rock climbing specific. And they can use that gym for $12 in a single day and pay $6 for shoes and $2 for a safety harness rental that day. You could also, as a student, buy a 6-month pass for $200, and you'd be able to go as often as you want and pay $6 for gear each time. So these are two different situations, and again, these are linear. We're going to compare them. And I'm going to compare them because I want to know how many times would I have to go climbing in 6 months to make the pass worthwhile. So this is what I'm going to do. I'm going to take my two options, because if I'm going to be comparing options, I need to be aware of what those options are. And my first option is, okay, I can either buy the pass or not buy the pass. So my first option here is I'm not going to buy the pass, and I'm just going to pay per day. So I need to figure out how much am I paying. So that's all of this situation. And I'm going to look at each of those numbers there and kind of figure out, like, how does that look in an algebraic term? Well, here, I could pay $12 a single day. Now, that 12 isn't just getting added once, because every time I go, every single day I go, I'm going to be paying. So if x is the number of days, and I should record that, x is equal to days that I go, then I'm going to pay 12x for going. And I'm going to just kind of underline underneath that so I know I've taken care of that number. Now, on that day, of course, that's not all I pay. If I don't have the membership, I'm also paying $6 for my shoes. And I'm not just paying that once, I'm renting those. So that means every time I'd go, I'd pay $6. And last but not least, I also would pay an additional $2 for a safety harness, because, hey, if I'm going to be using those ropes, I definitely don't want to fall to my death over here. So this is where I have not gotten a single constant, because everything I would have to pay repeatedly, not just once. And this ends up being quite expensive. I also have my option 2, which might also be quite expensive. So in option 2, I buy the pass. So this is going to be my pass option. When my pass is $200. Now, in 6 months, right, because that's the time I'm talking about a time period within 6 months, I will pay that $200 exactly one time. which means that I do not need an X after it because it's a one-time payment of $200. And at that point, I'm also going to then only have to pay an additional $6 for gear because they give me a bit of a discount. But the question is, do I pay that once or do I pay it repeatedly? According to the question, I pay it repeatedly because I'm paying $6 for gear each time. So that becomes 6x. Now that I know these two options, what I want to know is how many times would I have to go climbing to make the pass worthwhile? Well, you can do this with trial and error. I can just put in a bunch of things for x and see when will, okay, if I go 20 times, will this be more expensive than this one? If I go 4 times, will this be more expensive than this one? And you can solve it that way. But there's a quicker way. I can say, well, when are these equal? Because if I know when they're equal, I can figure out at that point, if I add one more, will option 1 or option 2 be more? So I'm going to write out these two expressions and set them equal to each other. And then I'm going to solve for x. So here, when I combine my like terms, 12 plus 6 gives me 18, plus 2 gives me 20, so I have 20x. And on the other side, I have 200 plus 6x. Subtract 6x from both sides, and I end up with 14x is equal to 200, which means just x would be 200 divided by 14, or 14.29 about. Now that means since x is the number of days that I would go or number of visits I would do, I would have to go a little bit over 14 times to have an exactly even payment. Now what that means though is which one will be more worthwhile, or when will the pass be more worthwhile? Well, notice how I pay a lot for the pass right away, but after that it gets cheaper with every visit, right? Because I'm only going to be paying $6 per visit instead of $20 per visit. So that means if I go more than 14 times, the pass will be worthwhile because I will be paying less than I would for that additional visit as opposed to option 1. So my final answer is more than 14 times. And then that would be up to you. Are you going to go 14 times climbing in half of a year? For me, the answer is yes. For you, the answer might not be. And that can determine how your payments go. Now that leads up to a follow-up question that's going to be very similar. A standard climbing shoe costs around $90. Now let's say that you want to figure out how many times you'd have to go climbing for it to be worth it to buy your own shoes. So if I look above, the rental for shoes is $6 each time. And my first option is, I could just not buy the shoes, I could rent it. It's going to be $6 per time, so that would be 6x, or 6 paid repeatedly. And remember, x still is that number of days that you want gone. My second option is to buy my own shoes, and I mean this price of $90, maybe you can find a better one, I don't know, but that would be only paid the one time until I wear through those nice expensive shoes, right? So what I want to see is when will it be worth it to buy my own shoes? And in order to do that, I'm going to set these two situations as equal to each other and see when they balance each other out. So if I divide both sides by 6, I have then my answer to that. 90 divided by 6 gives me 15. In other words, after at exactly 15 visits, it won't actually matter whether I bought or rent the shoes. I paid the same amount. So if I go more than 15 times, well, it's better to have option 2. Because if I went 16 times, well, I'd have to pay for them again, right? Which would be more money. It'd be $96 as opposed to the 90. So here, as long as I go 15 or more times, it's worth buying my own shoes because I'll have the shoes and I'll save money in the long run. Which also means if you look above, I have to go 15 times to make the pass worthwhile. But if I go 15 times, I'm going to pay just as much for shoes as I would if I just bought the shoes. So if I buy the shoes, if I buy the pass, it is worth it to buy the shoes, provided I have the money for it in my budget, which we know can be tough given what we did with budgets before. Go ahead and try out this health club one that is very similar to the ones above. Pause the video, and then once you're done with the problem, unpause it to see if you got the answers right. You should have gotten this for your answer. X is equal to 5, and it would be better to go with option 1 in the long run because you'd be paying only $5 per visit. So like if you went 6 times, you'd be paying a little bit less for that next visit. Let's check our final problem then, and this one's going to have another special situation. So the special situation that we're going to look at here are delays. What do you do when you know there's going to be a delay or a difference between the X values, or the number of days passed or the number of weeks passed that we had before? So when you face a delay, what you're going to look at is putting this into your equation, X minus whatever that delay is. So this is what a delay is going to look like algebraically. We're going to take off some of the amounts that we usually put into X. And let's look at how that looks in a problem here and why that would work in particular. So let's say George and Kenny are doing a weight loss competition. George weighs 265 pounds and loses 2 pounds every week. So here's our situation 1. In this case, it's not an option, it's just a situation, right? We have George. And George, let's see, 265 is where he starts. That's his weight at the very beginning. And he's not going to just like gain this every time. That's just that starting point or that constant rate. He's also going to lose 2 pounds every week. Now, since this is something that is every week, I'm going to be subtracting that 2, not just once, but every week. And let's just call it W this time instead of X. And let's say W equals the number of weeks. I could call it X just as easily, by the way, so if you'd rather use X, that's fine. I just like the W to remind myself that this means weeks. Also, make sure that you are subtracting here because we are taking that 2 off of the 265, not gaining weight, hopefully. I mean, otherwise this is really not looking good for George here. But we do have Kenny as well, and Kenny is our other situation. So Kenny weighs 270 pounds, and he's losing 3 pounds every week, which is really great, right? Like that's a healthy amount, but not, too extreme. So we know he's not like dying with this weight loss, hopefully. But the problem is, even though he loses that 3 pounds every week, and which I know is repeatedly, right? He started at 275, he's losing that 3 pounds repeatedly. So I know it gets the variable. He started 4 weeks after George. Now that leads us to a bit of a problem because I know that weeks here should be the number of weeks passed, but I want them to refer to kind of like the same thing. I don't want to have to put different numbers in. And like, let's say if I was asking, okay, can we have an update 10 weeks in? Well, you'd go, well, George has been doing this for 10 weeks. How long has Kenny really been doing it? Well, he's been doing it 10 weeks minus the 4 weeks that he was delayed. So he's actually been doing it for 6. And if I said, well, how about what was it, let's say 12 weeks in? Well, you'd say, well, George has been doing it for 12 weeks, but Kenny has been doing it for 12 minus those 4. He's only been doing it for 8 weeks. So each time what I'm really doing is I'm saying how many weeks minus the weeks that he was delayed, or minus 4. And I really want to know what that is before I multiply it by 3, right? Because I'm saying he's only losing 3 pounds for, let's say, 8 out of 12 weeks, right? Those 12 weeks minus the 4. So you have to make sure to have those parentheses there so you can find how many weeks he's actually been doing it prior to solving the problem. But once I have this and my delays in there, I can set this up just like I would normally, and that will give me the following equation. So I now have this equation, and I can solve to see when their weight will be the same. And we've been doing that for a little while now, so go ahead and try it out, and then check your answer after you found it. So here's that solution where you should have found W is equal to 17. And you can put that into your calculator just to see what they'd actually weigh at that point. So they would weigh 265 minus that 2 times 17, number of weeks they've been going. So they'd both weigh 231 pounds. And that should still work when you put in the second formula, 270 minus 3 times parentheses our W value, or 7.